Hello, this is Professor Puchovsky, and this is FPE 580B, Business Practices in Fire Protection Engineering. This is Module 1B, in which I will provide an overview of fire protection engineering markets, services, products, and stakeholders. To begin this module for this particular course, I'd like to just put up actually one question here to kind of get you thinking a little bit about fire protection engineering markets. Okay, and as we kind of go through this module in this course, we'll be talking about what it is that you offer as a fire protection engineer and who it is that you offer it to, i.e. the market. So the first question I want to propose to you is, what would compel an organization to engage the services of a fire protection engineer? Why would somebody hire you as a fire protection engineer? Whoever that somebody is. Okay? Why would they want to pay you money? What value do you bring to them? Why do they need you? Okay? What problems are you going to solve for them? Okay? Specifically, what are they lacking that you're going to bring to the table? Okay? So, and I just want you to think about that as we kind of go through this course. Is what is it that you bring to the table? Okay? And again, that would get back to what would compel somebody to hire you? And again, if as you go through your career and you can't answer that question, I think you're going to have a difficult time in being successful in terms of making money at this or providing some value. Okay, so again, what would compel an organization to hire you as a fire protection engineer? I've got a couple examples here, a couple photos to get us thinking about this. And as we go through this, when we talk about these markets, let's talk about, and keep in the back of your mind, is what are the services that you're going to provide? Again, what is it that you bring to the table? What products might you bring to the table? Okay, are you selling a good or are you selling a service? Okay, what is it about or what is it that you're going to help somebody with? Because in the end, that's what they're hiring you for. And then again, who are the stakeholders? Who are the people that you're going to have to interact with to provide these services and these goods or products? Okay, whether it's the person paying you, whether it's somebody that's going to actually install or make the product that you've designed or you've recommended in some way. Okay, who are the stakeholders? Who else are you going to have to work with to make sure that your recommendations, that what you bring to the table, gets properly executed or implemented? So what we have here is a shopping mall. And it's one that's been completed. Looks to be in operation, at least there's people in there. And again, you look at the shopping mall, and you will think, okay, well, how does a functioning shopping mall impact me? Or what do I have to bring to a shopping mall as a fire protection engineer? And we'll talk a little bit more in detail as we go through this module about what is it, again, that you bring to the table as a fire protection engineer. So you look at the shopping mall, and it's functioning, it's existing. And from a shopping mall perspective, what's happening? Well, there's people that are in there that are selling stuff to the public. You go in, you need something, you go to the mall, you go to buy it. Or maybe it's a dining establishment. You're still selling something, food. Or you're selling entertainment. Maybe there's a movie theater or some other performance that may be there. But you're trying to get people in there to spend their money, okay, consumers, to buy things. And so you look at this and you've got this building, this fixed structure. Okay, well, somebody owns that mall. It's unlikely all the individual tenants that are in there. Okay, somebody owns that mall. Well, you go back a step and you say, okay, well, somebody owns this mall, and they're probably leasing space to these tenants. So that's their value proposition. They're creating a space, okay, that's going to attract people somehow into this mall so that their tenants can sell more stuff. Because the mall owner isn't really selling any product. He's selling space. All right? He's selling space within the mall, or leasing it. So you take another step back and you say, okay, early on at some point, this mall owner, okay, or somebody that they bought it from said, hey, I have a good idea to put up this building, call it a shopping mall. Okay, I'm going to develop it, I'm going to invest money into it, and I'm going to build this thing so I can sell it off to somebody else who's then going to lease it out to other people who are going to sell things, and they're going to make money on rents and leases, whatever the case may be. Again, as a fire protection engineer, what's your role? What are you doing? What do you have to offer? Okay, anything? Well, again, if you go back to the early construction phase, or maybe this is an existing mall that's going to have some work done to it. Who knows? Who knows it's a mall right here. Well, we look back and we say, well, okay, what's going to happen here? We're fire protection engineers, so what are we concerned with? Well, we're concerned about safety from a fire perspective. All right, that's why we're going to school. That's why we're in school. Or we've gone and got this degree. So we're concerned about safety, primarily from a fire perspective. So we look at this mall once it's constructed, and again, early on, we don't have a physical structure. All we have is concepts, things on paper, things in somebody's head. So we look at this again thinking, well, what am I going to bring to the table as a fire protection engineer? So we look at this, and again, we're going to fill this place with a lot of people. And a lot of people in a public space means, well, what if something goes wrong? Because we're going to fill it with people, but we're also going to fill it with goods, with things that could potentially burn, all right? Contents, building materials. So from a fire safety perspective, we're going to say, hey, you know what? If this developer builds this mall, how is he going to build it in a way that is not going to impact the public in a negative way? I.e., if there is going to be some sort of fire event in this space, how can I ensure safety for all these people that are going to go into this space? Well, the developer, unless he's a fire protection engineer, and even if he is, or she is, probably isn't going to spend the time to do that. That's not their job. That's not their role. They're going to try to hire somebody else to do that, to make sure that this building that they build is actually going to be safe for the public. Because again, they don't want a place that's going to burn. They want a place that's going to be safe for their customers, or for their customers' customers. So again, as you look at this mall, they're going to hire somebody that has some expertise, that knows about potentially the fire hazards associated with this mall, okay, and the people that are going to be in there. Okay, so they're going to look for somebody with that expertise. Also, from a developer, from an owner's perspective, they don't want a fire in this place, one, because of the safety concerns, or maybe because of the safety concerns. We'll get more into motivations. But also from a business interruption perspective. They don't want a fire in this building that's going to slow down their operations. Okay? Even assuming if they did have a fire in this building, and everything went according to plan, nobody got hurt, there's still a period of time where this business may be out of business for a period of time. Okay? They can't open up immediately after some event. They're going to try to, but again, the longer they're closed, that means they can't make money. So again, you're going to have to bring in, or potentially you're going to come in here and again bring in some value from a fire engineering perspective. How do I keep this building operational to make sure that the risks associated with fire are minimized to both the enterprise and to the people that are going to be in there, the general public? And that can be, we can involve, or fire protection engineers get involved in a number of ways as you go through school and study these things, either by providing certain types of systems, sprinkler systems, fire alarm systems, smoke management systems, or providing overall strategies in terms of egress and how that building should be laid out so that it can accommodate a good fire protection strategy, or that you will integrate that fire protection strategy into this building. Okay. There's another potential operation here, or an operation rather. And here we have a refinery of some type, or a processing plant. So again, as a fire protection engineer, what do you bring to the table? Is this a potential market for you? Is this something that you can say, hey, Mr. Plant Owner, I've got something to offer you? Well, yeah, what? What is it? Why do I need you? Okay. Why am I going to spend money to hire you to do this? Well, again, if you look at this, well, this is slightly different. What do we have here? Well, we probably have employees of some type in this process plant. But how many? Also, what now is neighboring this process plant? What's around it that may be affected by these operations? Are the operations associated with whatever I'm manufacturing in this process plant, are they hazardous? How hazardous? How do I know? So again, you're going to look at that and say, as a fire protection engineer, what do I do? What do I bring to the table here? And on this particular point, as opposed to a shopping mall, where you may come in early on in the process when they're building it, okay, when they're designing what it's going to look like, when they're rehabbing that space, or maybe even you maybe get involved in that shopping mall as in routine operations, in terms of making sure systems remain functional. Okay, so they change things in that mall, that again you're analyzing the associated risks. Well, a similar thing occurs here with this process plant. Okay, you may get involved early on in the design and construction of this, What are the risks associated with making whatever we're going to make? Okay? How do we ensure that, one, we don't infect the people that are going to be within this plant and those folks that are adjacent to it? How far adjacent? What if something goes wrong? How far are the associated risks associated with this plant? Okay? So those are things that a building owner or developer or the operator of this plant would hire you for. Okay? And again, what services are you going to provide? Well, we're going to tell you how to make your process a little more intrinsically safe. We're going to design explosion suppression systems or detection systems for this plant to make sure that it remains operational. Again, looking at a business continuity or a business interruption perspective, what is it that's going to help? All right? And again, in terms of stakeholders, who are they? Okay, well, one is going to be the owner. Two could be what are called AHJs, the authorities having jurisdiction. Okay, those folks that represent the general public to make sure that this community remains safe. All right, we'll talk more about how they do that. Okay, other stakeholders might be insurance representatives. Somebody's probably going to insure this plant. Well, they're going to want to cut down their risks. So there'll be some stakeholders. Other stakeholders may be people that actually build or make the individual components to this process plant. Whether it's the components that you're processing the product in, or maybe there's safety systems that are placed in, detection systems of some type, okay, or explosion suppression systems. So again, think about this. What is it that you're offering? Who are you offering it to? How do you offer it? Here's another venue, sports stadium. Okay, large sports stadium. This one up here in the Northeast, Gillette Stadium. Okay. Again, what's the venue here? Well, the venue is to lease out this space either because you own the team that plays there, or you lease it out to other events, concerts, and other types of activities. Again, what are you doing here? Well, you've got a lot of people that are going to be occupying this space. What if something goes wrong from a fire safety perspective? Have you accounted for that? How much do you have to, or how bad of a situation do you have to account for? Would a building owner know that? Or is it going to rely upon you as a fire protection engineer to help figure that out? All right. So again, think about what services are associated with this, what products, and who are the stakeholders. There's another building, high-rise building. Okay. In this case, we're looking at this high-rise building, and again, in this case, somebody's developed this building, has built it. Right. Architect was involved in this, as they would be in the last 3 slides that I put up there. Okay, so you look at this particular building, say, well, again, as a fire protection engineer, what are you bringing to the table? Okay, what do you have to do? Lay out the egress. What's the building going to be made of in terms of its construction? Okay, how big can that building be? Right, from a fire safety perspective. What safety systems have to be in there? How big does the egress system have to be? What types of materials can I build this building on? What can I use for interior finish materials? What type of active fire protection systems do I need for this particular building? Okay, so these are the things that you're going to try to bring to the table to help the developer or whomever it is to make better decisions about that. I will tell you in this particular building it no longer exists because, well, it didn't quite burn to the ground, but this is One Meridian Plaza, which is in Philadelphia. There was a fire back in 1993, okay, in this partially sprinkled building. And again, the developer, the owners, probably could have used a little bit more help from fire protection engineers. Because if they had, this building would probably still be in existence. But again, there was a fire that occurred back in 93. It occurred, I believe, on the 17th floor. It occurred in a portion of the building up on the 17th floor that was not sprinkled. The building was partially sprinkled. It did have a standpipe system. Well, the fire started in a floor that was not occupied. Okay. The fire continued to burn in this particular building up to the 23rd floor. Right. Well, what happened? Well, I'm going to research all the details, but I'll tell you the outcome. All right. As the fire started and worked its way up through the building, again, it worked its way up to a point where, or it worked its way up through the building because it was not sprinkled. There was a standpipe system. Now, a standpipe system, if you're unfamiliar with that, is essentially 2 sections of pipe that rise up through the building that are to be are connected by the fire department with their hose so they can manually fight the fire. Okay? Well, oftentimes what you have with the standpipe system, especially in a high-rise building, you'll have pressure-reducing valves. Because as you get in lower floors with a fire pump, what happens, the pressure gets higher and higher as you get into the lower floors, because you need this higher pressure to overcome friction and elevation losses. Well, with these pressure-reducing valves, they need to be set appropriately. On this particular building, they had them on all these lower floors on the 17th floor, but they weren't set right. So when the fire department showed up and connected to the building, unfortunately there was not sufficient pressure, which means there wasn't sufficient water to fight the fire. As a result, 3 firefighters died in this particular fire. Also what happens is that fire was spread up to about the 23rd floor, where it did finally reach a sprinkler system, which helped contain the fire. Throughout the course of the fire, they were able to locate these devices that could be used to adjust the pressure-reducing device, okay, which would then allow a sufficient amount of flow. Prior to that, the fire department was running their hoses manually up 17 flights of stairs to these fire floors, okay, which took some delay, okay, and unfortunately resulted in the fatality of 3 firefighters. Again, once this, and again, from this particular building here, the fire continued to burn. Had it not reached a sprinklered floor, it has been surmised by many folks that that building would have collapsed during the fire, okay, because of just the nature of that fire as it worked its way up through that building and the heat associated with it. Now, this building, because of other reasons, but one primarily because of the structural damage that was done to that building, had to be taken down piece by piece in downtown Philadelphia. So again, had some pre-planning been done, okay, in terms of the systems that were designed for this, an overall fire protection strategy in terms of what would happen when a fire does occur, have people thought of that? Is that something you could help out with as a fire protection engineer to say, hey, there's some plan that should be followed, i.e., if we can't adjust the pressure reducing devices, how do we go about quickly? What are the devices that we need, or the keys that we need to arrange those or to readjust those pressure reducing devices? Okay. Had some strategy been in place, even with that, the outcome might have been a lot better, a strategy that you as a fire protection engineer could develop. Another aspect or a service that's provided is once the fire occurs, okay, in the aftermath. What do you offer? Well, you offer your forensic services. If you're an expert on certain types of systems, you can come in there and help piece together what happened. Why did certain things happen the way they did? And again, once a fire does occur, especially one of this magnitude, and especially one, even if not of this particular magnitude, but one where you're starting to make insurance claims, there's usually going to be some investigation involved, especially once there's life loss, absolutely. Depending upon the amount of property damage, there will be some investigation. So your forensics may come into play. How did the fire start? Why did it spread the way that it did? Why did the sprinkler system or the fire alarm respond or perform the way that it did? Okay. So again, from a fire engineering perspective, or fire protection engineering perspective, you'll be involved either before the fire, largely before the fire, by designing systems, providing advice, providing strategies, okay, or after the fire. Okay, usually not during, unless you're a firefighter. Okay, so it's usually sometimes before, and hopefully that before there's never a point where there's actual fire in the building that you've worked on, or after a fire event occurs, fire protection engineers get involved. So, moving on. Another question to think about. We talked a bit about what would prompt somebody to engage a fire protection engineer. Well, there's a slightly different version of that. It's what would prompt an organization to consider and engage in fire protection activities? Why would somebody want to do this? Why would somebody want to do fire protection? Because for the most part, if you look out there, unless you actually work for a company that makes fire protection products or offers fire protection services, why would somebody engage in fire protection? For the most part, it doesn't make them money. If you look at that shopping mall, if they invest all this money in fire protection, they can't turn back at the end of the year and say, okay, based upon our investment in fire safety, how much money does this make for us? Or for that process plant. you look at that and you say, okay, we invested all this money in fire protection systems and fire protection engineers and these strategies. What's the bottom line? Can I look and say, okay, I invested this money, what's my rate of return? It's a difficult thing to do, right? So people will look at that, and for the most part, they'll say, well, you know what, and some people are smart about it, and they'll say, well, I want to engage in fire protection activities because I know if I don't, then I can have a devastating loss. It can cut into my business in some way. So I'm investing in this, either in some active fire protection or into these strategies or buying insurance to help me guard against them. And even though you might have insurance, people will still do this, all right, because they want to make sure their businesses remain viable and do not get impacted by fire. Again, a large portion, you go back 100, 150 years, when insurance companies, the primary threat was fire. Okay, they were burning down not only just buildings, but entire cities. And that was a concern, okay? Less so today, but still a concern. So you look at this, and from a business perspective, it's one of those things where you can't directly look at fire protection, fire safety, and say, how much money is that going to make for me? So some people will do it. For example, I point to someone like Marriott Corporation, right? They go, and wherever you are, okay, around the world, you go in a Marriott hotel, you know it's going to be sprinkled. You know it's going to have a certain level of fire safety, even though the local rules or laws may not require them to do that. They will still do that because for them it makes good business sense, okay? And they care about the people that stay at their hotels, okay? Now, I don't work for Marriott, not endorsing, not an endorsement because I'm getting paid, but that's what they do, okay? And there's other companies that are similar to that, that will engage in fire protection because they see some value in it, whatever that may be. But for the most part, if you look at fire protection and why people do the things they do it, well, one, they may want to do that, but also they have to. They have to do it because primarily of building and fire regulations. So if you want to build something, either in this country or wherever you are, and again, there'll be different rules across the globe, you're going to be required to meet certain rules and regulations. And those rules and regulations are largely there to protect people from fire, or the effects of fire. So we can say that building regulations, for the most part, even though this isn't a course about building codes, they are important. It's important to recognize what they are and what they do. Okay? So in summary, the building regulations serve to legally and ethically establish the minimum criteria that must be met by the building owner in providing health, safety, and welfare for the public. Therefore, because of all our buildings are going to be occupied by people of the public, or could be located in areas that they will affect the public, they have to meet certain rules. They have to meet certain criteria to make sure they meet some level of safety. Okay? So oftentimes people are forced into practicing fire protection because of regulations. Right? And that's an important aspect in the fire protection business. It really is. People will go above and beyond building regulations, but they have to do at least what's in the code. And as a result, we'll see that building regulations, the way they're promulgated, largely influences the market of fire protection engineering. Okay? And we look at building regulations. Well, what are they? How do they work? Well, here's some. Okay? Depending upon where you are. And again, these are U.S.-based regulations, but they're also used around the world. You've got the building code, the international building code. And there are later editions of all these codes. There's fire codes. Okay, so you've got the International Building Code or the International Fire Code that is shown here. Okay, you've got on the right side here the Life Safety Code, NFPA 101 or NFPA 1, their fire code. Okay, you've got installation standards such as NFPA 72, which is the National Fire Alarm Code, tell you how to install a fire alarm system. Or in the lower right-hand corner, NFPA 13, standard for the installation of sprinkler systems. Again, will indicate what systems you might need, or actually how to install and design that particular sprinkler system. Now, all these rules that are around here, whether it's the International Building Code, it's put out by the ICC, or NFPA 101, put out by the NFPA, these are model legislation. Okay, so these organizations are private companies, all right, that put out these codes. And then it's up to some jurisdiction, whether it's the city of Boston or the state of Massachusetts, okay, or the city of New York, whatever the case may be, will adopt some version of these codes and then modify them to fit their needs. Okay, so they become law. And all of these codes that are put out there by NFPA, the ICC, or anybody else within the United States, they're written in such a way that they can be adopted into law. So as you look at them and pick them up, and you will do that in other courses and a little bit in this one, you look at that, it'll tell you, you shall do this. You have to do this based upon whatever type of building you might have. So you're required by law to engage in some sort of fire protection activity. And again, these become laws. Right? And oftentimes, just like if you were practicing accounting, there's accounting rules that are out there, or some other legal aspects or legal issues, you may not know all the rules or all the details. You don't know that practice, so you're going to hire somebody else, i.e. an accountant or a lawyer, whatever the case may be. Well, for this application, because of building regulations and so much of it is geared around fire, well, you probably hire a fire protection engineer or a code consultant or somebody that knows something about fire to help you make these decisions that you have to comply with. Otherwise, you can't build your building, or you get fined, or it'll delay how quickly you can build your building. And again, you don't want to run into those delays, because from a business perspective as a developer, you want to get that thing designed and built as quickly as you can, and operational, start making money. That's your investment. So you'd hire a fire protection engineer to help you implement these codes and standards. All right, so we have building regulations, which largely drive to a good portion of what we have to do. And again, as I said before, these are minimum rules. You can go above and beyond them, and some people do. Oftentimes you have to, because these rules, these building regulations, right, they will give you minimum requirements. But what's in those codes may not be enough for you to successfully maintain your operation. You may need to go above and beyond that, because this is concerning life safety. From a regulation standpoint, the public really doesn't care about how well you operate your business, for the most part. I mean, they may from some non-direct way, i.e. you have a large fire in this big factory in your community, and it's forced to shut down. Well, that's going to impact the community, because, well, now all these jobs have to go somewhere else. And, if that building was properly designed, looked at by a fire protection engineer, maybe that fire hadn't happened, and you maintain those jobs in that community. So it's all very much interconnected through economics here. Okay? So again, we're talking about these building codes as being a minimum standard, and they're really not there for property protection or protect your operation, but really to protect the general public that may be in that building or adjacent to it. Well, if we look at building regulations in general, and this is how we start breaking down a little bit into, well, what is it that a fire protection engineer might do, and again, driving as to what that market might be for you. Okay? Well, one is the building codes, the fire codes, well, building code primarily is going to talk about building construction. All right? It's going to tell you, well, what's the size of the building in terms of its height and area? What type of structural fire resistance might you need? What types of fire containment would you need? What type of interior finish materials could you have in that building? Okay, what lines the walls, for example? Well, that's governed to a good deal by building regulations. And again, you can look at that, but again, the fire protection engineer will come in there and say, hey, I can help you interpret those rules, apply those rules. And oh, by the way, what happens if the building you want to build doesn't quite fit within the regulations? Then what do you do? Maybe you want to build a building that's bigger than what the code would allow, or build it out of material that doesn't quite have the structural fire resistance as is specified, or the fire containment, because it's going to impact the overall functionality or design vision that the developer or architect might have. So a fire protection engineer, if they know the code very well, will come in and say, hey, I know fire. I've studied it. I know fire protection engineering. I can help you, Mr. Developer or Mr. Architect, or Mrs. Architect, in terms of applying the code and coming up with some other solution. Also, from a building construction perspective, you're looking at this, again, we're taking this from the code, but again, who is going to design this? Who is going to ultimately design the structural frame to have this fire resistance, to design these different types of assemblies that are going to have this fire resistance rating, or the interior finish materials? Again, fire protection engineers may help or do design those systems. Okay? They'll actually stamp the drawings and assist and design and help make decisions about that. You may also get involved in the actual products and the assemblies, okay, of what type of spray-on fireproofing or the interior finish materials, helping a manufacturer of these types of materials develop and have these materials tested and approved by some third-party laboratory that has to make sure that they meet some standardized fire test. Oh, and maybe a fire protection engineer is going to be involved in setting those particular fire test standards or those installation standards and get involved in a process such as is in NFPA or ASTM, American Society of Testing of Materials. Okay? Same thing with active systems, right? In terms of what a fire protection engineer might bring here. Okay, is again, help the owner. What types of active systems are needed? How do you design them? Well, design the systems. Who selects what components to put into that system? Again, a fire protection engineer does that. Also looking specifically at the active systems in terms of what are the actual components that need to be manufactured. So as a fire protection engineer, you would be working for the manufacturer of a sprinkler manufacturer, or someone that makes valves for a standpipe system, or water mist nozzles, or the entire system. You may work for a detection manufacturer. Whatever the case may be, still, if that's what you do, working for them, you still have to know the codes. Again, we're still within the building regulations. You can't just go design whatever thing that you want, whether it's a fixed product or something that you're going to use as a component of a larger system in the building or some other process plant. It all comes back to the building regulations. You have to know that. That's what you bring to the table. I know that code. I know what it wants. I know fire. I know how to come up with a solution so that we can build your building. Okay? That's potentially what you're offering. Right? And we go on to the other systems that are covered in building regulations. Emergency power systems, smoke management, as we saw in that mall a couple slides ago. Again, pretty much every mall, it's going to be of a certain height or a certain size, is going to require some sort of smoke management strategy, which will involve a smoke management or some extract of smoke from that area. And again, from a fire protection engineering perspective, well, who's going to design that system? Who's going to spec it out? Who's going to tell the installing contractor what to do? And the fire protection engineer. It's one of your roles. Who's going to actually design the components? Okay, you could work for a manufacturer that actually makes these things. All right, moving on, means of egress. And again, just some other items that you be involved with. Who's going to set the strategy for number and capacity of exits, their arrangement, how they're lit, how they're marked? Okay, what's the overall egress strategy? So again, from a fire protection engineering perspective, you can get involved in many fronts in terms of making decisions about this. And lastly, we have here is building contents. What types of things should be allowed in the building, and how do you regulate that? All right. Again, driven by building regulations. All right. And again, people are going to have to do this because primarily that's what they're required to do by law. So again, having some knowledge of that is definitely beneficial, regardless of who you work for. You need to know the codes. Okay, I want to spend a little bit of time just looking at some of the statistics in terms of fire. Okay, what is the fire problem? Because again, people are going to be doing fire protection engineering in terms of a market. Well, what is the market potentially? And again, when we say fire protection engineering, well, we're going to try to cut into this. We're going to try to cut into the numbers of fires because fires are undesirable, both from a life safety perspective and the fact that they impact negatively on our business and on the economy in general. I've got some statistics here, and they're kind of old, but from 2005, and some of your reading assignments associated with this get into this as well. But in 2005, we had roughly 1.6 million fires reported to fire departments in the United States. About a third of those were structure fires. Okay? And of those, 78%, roughly 80%, were structure fires, were residential. All right? Another 300,000 or so were vehicle fires. So a significant amount of fires that actually occurs on a yearly basis within the United States. Okay? So again, there is still a fire problem. Again, the problem goes away when we have no fires. Well, there will always be fires. And of all these fires, what is it that you offer as a fire protection engineer? To help cut down on this, or, again, once a fire does occur, what do you bring to the table? To who are you bringing it after a fire occurs? Looking at, again, just some statistics here, we can see the overall trend seems to be pretty much downward from the number of fires, going from what, about 3.2 million or 3.3 million fires in 1977, dropping down to about 1.6 million in 2005. And again, these statistics can be obtained from the National Fire Protection Association, NFPA, and NFPA comes out with these reports on a yearly basis at different for different operations for different types of buildings. Okay, and again, we can see there's a general downtrend in terms of the fire problem. You think fire protection engineers had some impact on that? Probably. What impact? How much bigger of an impact could you potentially have? Looking a little bit further at this fire problem in the United States, let's look at deaths, okay, because that is obviously a statistic that really hits home. So how many people actually die as a result of fire? And again, we look in the United States in 2005, there's roughly 36, almost 3,700 deaths from fire in 2005. Okay, so 3,700 people, okay, that died where they didn't need to. Okay, again, roughly 3,000 deaths come from residential fires. Again, looking at residential fires. Well, actually, let me do that. Let me see if I can get my. I guess I can't do that. It's not what I want to do. All right. There it is. Okay. So I want to get a pointer here. There. So again, we can see in here, we have roughly 3,000 deaths in residential fires. So again, still, from all the fires that we have, we can see a great percentage of them occur in residential applications. All right. So again, as I mentioned previously, a good portion of our business, the fire protection, is driven by codes and regulations and changes that get made to those codes. So again, there may be some changes along the way with regards to residential sprinklers that could have a significant impact. Okay. Let's look again at property loss. And we look at the property loss from fire, and it's a pretty big number. And again, I believe these statistics are from 2005. Again, there's a homework assignment that will ask you to take a look at some of the more current statistics and values as a result of fire. So again, we look at the property loss. If I can count that high, it's roughly $10.8 billion in property damage. All right, you got roughly $8.3 billion in structural property, and then a little lesser number there in residential property. Okay, as a result of fires. Okay, so again, looking at the total losses from property, and this doesn't even get into business operations. How much money was lost as a result of the fact that there was a fire in some facility that could no longer operate? And now that either that business goes out of business or it needs to relocate and move elsewhere. Nice. So what are those losses associated with all these sort of these secondary effects as a result of these fires? So again, a significant dollar value here. Okay. And again, we can look at this and you can see for the most part, while the number of fires have trended down, the property losses, the values from these fires, has actually gone up. You can see there in 2000, it's like 2001, you get the spike. That's largely from 9/11. And you can see we were sort of trending upward in terms of value or the impact of these fires, because again, things are getting more valuable. For one, the numbers of fires have gone down. Some of the fires have been more significant from a property perspective, okay, from a value perspective. Okay, so kind of trending upward there. Right? And again, the source of this is for the NFPA. So you think about this and trying to define a market is what impact might you have? What do you offer as a fire protection engineer to cut into this? To say to somebody, hey, you know what, this is what the property losses are. By engaging in my services will help you cut down on that and keep more of your money so you don't have to pay that out. Okay? And insurance is obviously a large component of this. Well, let's talk a little bit here about the function and responsibility of a fire protection engineer. Right? What is it that you do? Specifically, what might you do that somebody would pay for? Okay, you got to think about that. Again, what's your value? All right. Now, one thing I did here is I wanted to put up just a job announcement. Okay, and this is a fairly recent job announcement that we get here at WPI. But again, it says here some engineering company. All right, and it says here FP job announcement. And again, this is an opportunity to build your world. All right, XXXXX is the engineering company. It says it's integral in creating the world of tomorrow as one of the largest and most diverse providers of professional technical services, whatever that means. Okay, with an annual revenues approaching $6 billion, pretty big company, we offer a full spectrum support to industrial, commercial, and government clients across multiple markets. All right, so they offer a whole bunch of stuff in terms of engineering solutions, it sounds like. All right, services include scientific and specialty consulting, all right, whatever specialty is, as well as all aspects of engineering, construction, operations, and maintenance. All aspects of either constructing a building or maintaining its operations, and then maintaining those operations so that the business remains viable and profitable. And this company is consistently recognized as the best managed firm in its industry. People of XXX are trusted partners in every global region, so it's a global company. And it says, join us now and build your world. All right. Talking a bit about that. And again, this is an aspect we're trying to define, and these people are trying to appeal to somebody to come work for them. And from this, you can see what they do and what they offer their potential clients and who their clients might be. Right. What we're looking now specifically is, well, what is a fire protection engineering job announcement? All right, and again, this goes with this job announcement on a preceding slide. It says provide fire protection engineering. All right, we've got design, all right, designing systems, calculations, modeling services for clients in other XXX offices as required. All right, so some of the services you provide, what are you selling? Well, I can design something. I can do some calculations to demonstrate my design works, and I can model some things, i.e. more detailed calculations. All right, involved in doing what? Well, let's see here. Suppression, alarm, detection, and structural fireproofing design. All right, designing that. In terms of design, you're going to lay something out. You're going to tell somebody how to build this suppression system, this alarm system, or this structural fireproofing system, either in drawings or through some specifications. You're going to lay that out, tell somebody how to build it. Going to get involved in explosion, fire, smoke, and dispersion modeling and our calculations. All right, do you know anything about that? As a fire protection engineer, can you model this, explosions, all right, or the dispersion of products of combustion, whatever the case may be, something that someone needs to know about. That's what you bring to the table. Okay, to whom might you bring this to? Code and life safety analysis and reviews. You need to know what the code says. You need to analyze what the code says. That's a service because the developer, the architect maybe, whoever is going to be paying you, doesn't want to do it, doesn't have the skills to do it. That's what you bring. Okay? That's what you bring. And again, towards the end, you're going to think about, well, how much am I going to have to charge for this? What's reasonable? How much is it going to be for this job? And we'll get into that throughout this course. You've got to maintain here a working knowledge and understanding of the National Fire Protection Association codes. Yep, need to know codes, state and municipality codes, and client-specific requirements. All right. So you need to know what the model codes say. Here specifically NFPA. They don't specifically say IBC, but that's what state and municipality codes are. The building codes are primarily derived from the IBC as the model code. Okay. And any other specific client requirements. Maybe you end up working for some oil company that's got their own set of regulations. You got to know. Okay. Conduct facility evaluations for compliance with procedures and fire protection codes and standards. Identify deficiencies. Recommend corrective actions and provide necessary technical support to resolve issues. All right. So, again, what are you doing here? From a fire protection perspective, they want you to make sure the building's safe. You're complying with codes, other practices. What's the problem in terms of fire? Help us figure that out. How do we know we've got a fire issue or fire safety issue? You're going to have to figure that out first. That's what you bring to the table as a fire protection engineer. Okay, great. You've analyzed we have this problem. Why do we have a problem? Prove it to me. And if you do have this problem, don't just give me your problems. Tell me what your solution is. What do you recommend that I do to fix this problem? And oh, by the way, how much is it going to cost me for this advice that you're giving me or for this solution? Or how much is it going to cost for me to buy that particular system or those components? And then again, the last part here is evaluate alternative means or alternate means and methods for achieving code compliance. Now this is another thing. We talk about performance-based design as a fire protection engineer, and that's what this is, alternative arrangements. Performance-based design fits into that. What if I can't quite meet the letter of the code? What do you offer me? You as a fire protection engineer, in your training and your services or what you or your company does, can you make sure my building is safe and, oh, by the way, still meet the code and the rules, the letter of the law? Can you find another way for me to do that? Maybe. That's what you do. That's a service, a tremendous service you're providing to a potential client. And again, look at requirements. Well, what do you need? Bachelor's degree in fire protection, mechanical or chemical engineering, at least 1 year experience in computational fluid dynamics, some skills specifically on CFD modeling and analysis required, and I'd like an EIT, right, or FE. I don't even think it looks like a, actually call it the Fundamentals of Engineering exam now, not the EIT, so some old terminology there. And again, while I'm on that subject here, if you haven't done so already, take your FE, your Fundamentals of Engineering exam as soon as you can, and sit for your PE exam as soon as you can. Okay? The sooner you get that behind you, the better off you will be, and the faster you can practice as a fully registered fire protection engineer. All right, here's another FPE job announcement, and again, I just want to kind of put these up as to what's needed. This might be a bit repetitive, but again, a BS degree in fire protection engineering for this particular job. Fire protection or safety engineering technology related discipline. So that degree becomes very important. People are looking for that. Knowledge of codes and standards in the International Fire Code in this case here, the second bullet item. All right? Again, you have to know the codes. Do you bring that to the table as a fire protection engineer? Whether you can work for a developer, you're going to work for some organization, whether it's Marriott or somebody else. That was Marriott. I mumbled there for a minute. Or is it going to be because you're working for a product manufacturer? You're still going to be bound by certain rules and regulations. You need some computer skills, obviously, which is the third bullet item. Okay, and these don't necessarily get into CFD modeling, but you may need those. And then the last one here is some other software skills, previous use of fire sprinkler design software, fire modeling programs, early warning smoke detection design programs, and maintenance management programs. Right? All required. Your knowledge of these, or your possession of these skills, become marketable. That's what you're going to try to, that's part of your value proposition. All right. Well, let's look a little more specifically at FPE functions. All right, and you can get some of these from various sources. I think I pulled these actually from the Society of Fire Protection Engineers. But you look at this, and again, from a fire protection engineering perspective, what are you doing? Well, you're using science and technology to protect people, property, and business operations from destructive fires. Ultimately, that's what you're doing. You're making sure a fire doesn't get to the point where it becomes destructive in some way. You also need to analyze how buildings are used. All right? What's the operation in that building? That becomes important. That's going to drive your decisions. All right? You have to have some understanding of how fires start, how they grow, how fire and smoke and byproducts affect people, buildings, and property. Okay? Because again, you need to know that a fire in one operation, whether you're storing iron or steel, whatever the case may be, bricks, that fire may have a different impact than where you're storing computer chips or medical equipment. Okay? So there'll be different hazard analysis, a different impact that you're going to have to be aware of. You need to know that. That's what you bring to the table. Other functions. Well, you design systems that control fires, alert people to danger, and provide means of escape. All right? That's what you bring to the table. You evaluate buildings to pinpoint the risks of fires and means to prevent them or mitigate their impact. You conduct fire safety research on consumer products and construction materials. Right? You may be conducting or working for a laboratory that conducts research. All right? You may be doing research to develop other CFD models or future algorithms within those CFD models. And lastly, you may investigate fires to discover how fire spreads, or why protective measures fail, and how those measures could have been designed more effectively. And also from fires, you may learn how to change future codes and standards. Okay, all part of what you might do and ultimately what you're trying to sell to somebody. Work with architects and other engineers, state and local building officials, and local fire departments to build and maintain fire-safe communities. Well, again, those are some of these stakeholders. Who are you going to work with to make sure that that overall community remains safe? Okay? Again, you're looking at this, it could be the broader community, or it could be specific to that building, that large mall, that industrial plant, that sports stadium, whatever the case may be. How does it fit into the overall community? And then you make recommendations. Make recommendations for cost-effective fire protection solutions to ensure, again, that property operations and occupants are adequately protected. Okay? So you talk about cost-effective. What's cost-effective? Most bang for your buck. Well, how do you know how cheap to be? All right? And when you talk about are adequately protected, well, what's adequate? 0 deaths? No one gets hurt? What is it? Right? How do you figure that out? That's a complicated question. But still, that's one that fire protection engineers have faced, and that's what you've got to deal with. Okay? And that's what you're going to help your client, your customer, solve. In the end, you know, I think it boils down really to this. As a fire protection engineer, you're going to make decisions, which will get put forth in some sort of recommendations about fire safety. That's what you're doing. You're going to make these decisions and these recommendations, right, about fire safety. That's ultimately what someone is going to pay you for. All right? They're not paying you to kick a soccer ball or play basketball, right? They're paying you to make a decision about fire safety, one that they can't make, or they're not well qualified to make, or maybe ultimately it will be them who make that. All right? They're the ones that will make that decision, but you're influencing them. Okay? And this can go all the way up the line. This could be you influencing your boss, your boss's boss. It could be you influencing your client. It could be you helping your client influence their client. Okay? Whatever the case may be. So you're either going to make the decision or you're going to influence somebody's decision about fire safety. And that's what everything else is. The codes, the standards, the computer models. In the end, somebody's going to have to build something or do something. And they don't know enough about it to make that appropriate decision. And that's what you're bringing. So in terms of fire protection engineers, well, what do you find them? Well, you guys either have jobs or you're about to get jobs, but you could work for engineering firms, right? It's a consulting fire protection engineering firm designing systems, providing advice to your clients, all right? Structural systems, sprinkler systems, fire alarm systems, smoke management systems, egress systems and solutions. You may work for a contractor or installer. You're working for the actual outfit that's actually going to take what you as an engineer have told them to do and make it work. Actually construct this building, this system, whatever the case may be. All right? You may be working for them. All right? You could be a governmental authority. All right? Well, CFPE's there. What are called authorities having jurisdiction. All right? And when we talk about this, it's going to be the person or the entity that represents the public interest. And the public interest is represented how? Well, typically through the building regulations. That's how they're represented. And a building official, a fire official, electrical inspector, whatever the case may be, is representing the public to make sure that those regulations get complied with. Okay? There may be also other governmental authorities that you may have to deal with. There may be people beyond that. There could be a historic preservation committee that's out there that you may need to comply with from a fire perspective. They may not be fire protection engineers, but you may be brought into this project because they want to renovate this old building, and it just so happens that this old building has some historic significance to it. And if you try to apply the code directly to it, you'll find out you'll destroy the historic fabric of that building. And the historic preservation committee of that town will say, no, 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 we can't do that. So you have to work with them. So what do you bring it to the table? Other ways to make sure that building is safe and still preserve the historic fabric of that particular building. Maybe you work for a fire equipment or a system manufacturer. Right? Again, you still need to know what the regulations are. But again, how does your product fit into the bigger picture? What advantage why would that company hire a fire protection engineer to help them with that? And many of these system manufacturers do. They need folks that know fire, know the codes, know what the risks are that are out there, and ultimately, what's the market for that particular product? Why are you making that product? How do you make that product so either it's more efficient or it covers a larger segment of whatever market you're trying to get to? Again, what are you as a fire protection engineer going to bring to that equation for that manufacturer? Facilities and operations folks. You may be the person running that facility, nuclear power plant, some other process equipment. All right. It could be maybe you're the corporate fire protection engineer for a large hotel chain. Whatever the case may be, you're the person responsible for some fire protection engineering component, making sure that that building remains fire safe. Maybe you work for an insurance company. Again, looking and representing that insurance company to make sure that their investment is, oh, by the way, we think we can insure this company because you're going to do these certain fire protection measures. And based upon that, when you pay us this premiums, we're betting we're not going to pay out a loss over a period of time. Okay, so we're going to give you that insurance. We're going to hedge our bets based upon some decisions that you as a fire protection engineer are telling me, the underwriter, about that particular company that you just went to go take a look at. There's also research and testing that you may be involved with. Okay, whether it's working for someone like NIST, Underwriters Laboratories, whatever the case may be, Faction Mutual, all right, conducting research, all right, about trying to better understand fire behavior and its impact on certain systems or products or people. All right, and again, from a research perspective, gets tied into also to various aspects, but there, you could be doing research as part of working for an equipment manufacturer, trying to figure out state-of-the-art technology, detect a fire faster, look for other fire signatures, whatever the case may be able to put out that fire with less water or with less agent, whatever the case is. And the last item that I have here is forensics that we've talked about. Again, from a forensic perspective, you're coming in and looking at why did the fire start? Why did it develop and behave the way that it did? Why did that fire have the impact that it did? Why did various fire protection systems fail or not perform the way they were supposed to? All right. You'll be brought in as a fire protection engineer, and that's what you bring to the table. That's your value proposition. So FPE services, well, what are they? Well, again, this is kind of a nutshell here. We're looking at consulting engineers, all right, designing systems, services, all right, strategies for people to engage in or to follow. You could be designing systems, again, whether they're fire alarm systems, sprinkler systems, clean agent systems, smoke management systems, all right. Building code consultants. You know the code. You know what it says. You know why those rules are there from a fire safety perspective. Okay? Because you know that, you're able to come up with other options or help people comply with the code. Maybe you do peer review. Okay? Oftentimes, well, not often, but in certain jurisdictions where performance-based design is done, is more elaborate engineering analysis, there needs to be peer review. Okay? You're reviewing somebody else's work. You've been hired on by the municipality to engage in that activity because they don't have the people on staff to do that, because they don't have that many of those types of projects. So they'll hire a fire protection engineer to do that. Again, we've talked about forensic analysis and what you would do in that regard. Again, risk and hazard analysis, maybe from a corporate standpoint. What are the risks and hazards associated with fire? I don't know as a developer, as the owner. I'm hiring somebody, either on staff or a consultant, to help me with that. And then again, loss control. Largely could be from an insurance perspective. I'm a loss control representative. I'm going out there to determine what my potential losses might be from fire and how do I mitigate those or control those. And it could be because you're working as a fire protection engineer for an insurance company, or you get hired by the insurance company to conduct these services, or by some other entity to do the loss control. Well, again, in terms of products, well, kind of, again, in terms of summary, building and construction elements that are out there. Individual components on those systems, okay, that you would be working for a company that makes those, whether they're going to be sprinkler systems or whether it could be spray-on fireproofing or fire caulking material, or whatever the case may be. You may get involved in terms of software development, okay, because you're trying to come up with this commercially available software. Or maybe the software is proper or specific to a certain type of system design, i.e. water mist systems. How do we calculate how much water we need? Very complicated system. That software is proprietary. Maybe you work for somebody or that develops those. Okay? And then again, third-party product certification. In terms of fire protection engineering, pretty much all the products that are out there have to be third-party certified. You will find on these a UL label or FM approval or something from Intertech that indicates that that particular product has been evaluated by this laboratory under some standardized tests. And maybe you're the person doing that analysis. Maybe you're the person going out there to each one of these companies and saying, hey, are you still manufacturing that product the way that you specified that it was going to be? Because it has this fire safety rating or label placed upon it. Right? And again, to summarize stakeholders. All right? Stakeholders are going to be, well, who are these people? Who are the people that are going to be involved? And some of these stakeholders could be ultimately your clients or customers. Is it the owner, the developer, or the investors in a particular project, i.e. that shopping mall, or that chemical process plant, whatever the case may be? The public officials, the building officials, the fire marshal's office, the electrical inspector. All right? They're stakeholders because they're the ones that have to make sure that you comply with the code, and they largely influence how your job goes. Architects, right? Maybe you're working directly for an architect, get hired by an architect, because from a construction perspective or a building perspective, they're typically the architect of record and responsible for obtaining all the permits and everything else. And they'll hire engineers to help them with these other systems, help them comply with the code. Okay? So maybe you're working directly for the architect. They're your customer. Facility operators, right? Maybe you get hired by a particular facility, the owner of that facility or someone that works there to say, hey, I'm running this chiller plant, whatever the case may be, we need some renovations here, upgrade our fire protection systems. They're the stakeholder that you're working with directly. Okay? Product and system manufacturers, those folks that are going to actually supply the components that make up the overall system. All right? You'll be involved with them on a particular application. For example, where a fire pump is involved. Where you have a fire pump installation, well, who's going to be around there when that fire pump gets installed and we're testing it to make sure that it works right? Well, you're going to have someone there from representing the fire pump manufacturer certainly going to be there. Okay? As is the design engineer, as is the public officials, is likely somebody that represents the owner of the building. Okay? Listing laboratories. All right? Listing laboratories here. And again, talking about the listing laboratory, somebody like a third-party certifier, Underwriters Laboratories, Faction Mutuals Approvals, Intertech, all right? Engineers. There could be other engineers that you'll be involved with, that you'll be working with, all right, that you'll have to coordinate with. If you're working on structural aspects of fire safety, you're likely working with the structural engineer. If you're working on fire alarm, you're likely be working with the electrical engineer, okay? Contractors, all right, be working with them. They'll be stakeholders. Okay, that'll influence how well your job goes. And when I say how well your job goes, we're looking at it in two ways. One, how well can you implement your design? And also, in the back of your mind, when you're doing any type of job, working anywhere, if you're spending time on the job, you're spending money. The faster you can get everything resolved, the more money in, i.e., your pocket, or your boss's pocket, your employer's pocket. Okay, the more profitable the job. Okay? So again, you want this to work as smoothly as you can by working with all these stakeholders in the most efficient way. And then also insurance will come into play, as we've discussed. Okay? In terms of them being or having some impact. Maybe you've met all the building code requirements, but the insurance company comes and say, no, we're the insurance company here, and we ask you to do a few more things if you want us to insure you. So how does that impact your overall design and recommendations from a fire protection engineering perspective? Yeah. So if we look at this in terms of FPE markets, we talked about a number of different things, and there's a couple assignments that are going to be put forth that you should, that you will have, or do have, I should say. They're going to ask you to look at these things, and again, look at this from your own individual perspective of what you do or what you want to do once you enter the marketplace, i.e., you start getting paid for your services. Okay? The fire protection engineering markets, what are they for you specifically? Okay? What's your market? Well, if you don't have a job yet, your market's going to be a potential employer. But once you do have a job, your market's going to go, who are you going to sell your services to or your products to? Okay? Who are your customers specifically? Who are these folks? Okay? What do you offer specifically? Okay? What is it? Is it a product? Is it a service? What specific type of service are you going to be offering? Okay? And ultimately, how do you make money? How are you going to make money on this particular job or by selling this product? All right? How do you make that money? All right? How much money do you need to make? All right? How do you know when you're profitable? And again, we'll get to some of these things throughout this course, but these are some of the basic questions you should be asking yourself as we go forward. All right. This concludes Module 1B in terms of just the basic overview of the market of fire protection engineering, some of the products and services, and who some of the stakeholders might be. Now, again, since this is an online course, by all means, please email either me or Professor Krein with your questions, and we will get back to you. Okay, this concludes Module 1B.